This video reviews the different test parameters measured by the EC series analyzers and reported in IBMS. The EC series analyzer measures three test parameters: voltage, impedance, and global energy innovations parameter, cell scan, which assess the chemical properties of the batteries. The interpretation of the test parameters is supported by means of alarms. If one or more of the parameters fails the alarm conditions, the battery will have a warn or a fail status. Warn means that the battery should be monitored more frequently, and fail indicates that the battery has reached the end of its life and should be replaced. Alarms used in the EC series analyzer and IBMS are customizable to match any battery chemistry. Voltage is the basic reading to assess the condition of a battery. If the voltage is too low, it most likely means that the battery is not fully charged. This is a precarious situation since an insufficiently charged battery will fail to deliver the expected capacity, and failure corresponding to an uncharged state, such as sulfation for lead-acid batteries, are more likely to develop. Likewise, failure will also develop in batteries showing high voltage. For example, a high-flowing voltage for lead-acid batteries accelerates grid corrosion, promotes dryout, or can lead to dangerous situations such as thermal runaway. Therefore, it is important to ensure that the battery voltage is within manufacturer's specifications. This is achieved in the EC series analyzer and IBMS with the use of alarms. Any battery with voltage not falling within the alarms will be marked as warned or failed. Based on such results, you can take preventative action to recover the battery and minimize the risk of a dangerous situation. The impedance reading relates to the electrical properties of the battery. It includes the integrity of the bus bar inside the battery, the conductivity of the battery electrolyte, as well as the analyzer connection. For this reason, it is important to always connect to the battery in a repeated fashion. Global Energy Innovations recommends connecting on the battery terminals. Impedance readings from connections made onto bolt or straps attached to the battery terminals will include contributions from the bolt and strap. It may not be reproducible over time, leading to a misdiagnosis of the battery's health. The impedance readings will be reported as a raw value in milliohm, but are also normalized to a population-based reference corresponding to the best battery impedance in the string during the first measurement. In this case, the impedance is reported as a population reference percentage. When IBMS is configured in advanced view mode, each battery impedance is also normalized to its own battery impedance measured during the first test. In this case, the impedance is reported as a self-reference percentage as each battery uses its own reference. Impedance is a better indicator of battery health than voltage. As the battery ages or degrades, the battery impedance will increase while the voltage can still remain in the manufacturer's specified value. Based on the default alarms in the analyzer and IBMS, a battery will be marked as failed when impedance increases by 25% of its original baseline. A common rule of thumb is to replace a battery based on impedance readings. The cell scan parameter indicates the chemical properties of the battery based on a multiple frequency impedance scan. For lead-acid batteries, the cell scan parameter is also reported as sulfation. When the lead-acid battery is based on valve-regulated technology, dryout will also be available. Sulfation and dryout values correspond to the percentage of capacity loss due to sulfation or dryout. For example, a 10% sulfation reading indicates that the battery capacity has decreased by 10% of its nominal capacity due to sulfation. Sulfation and dryout alarms are set following the IEEE recommendation on load testing. IEEE recommends replacing any battery which during a load test falls 20% below its nominal capacity. The EC series analyzer and IBMS will indicate any battery that has a 20% sulfation or dryout as failed. Please note that other degradations can also develop in a battery, and the use of an EC series analyzer is not a substitute for a load test. Because cell scan deals with the battery chemistry, it is a better indicator than impedance for assessing battery degradation. Thanks to cell scan, you will be able to detect if batteries are in an early stage of degradation. By implementing preventative maintenance, you will be able to maintain your batteries and maximize their service life. Cell scan values are reported as relative degradation for non-lead-acid batteries when IBMS is configured in advanced view mode. As for impedance, relative degradation is reported according to a population and self-reference. There are no alarms for relative degradation, and the interpretation of the results is left to the user. For optimal testing conditions, Global Energy Innovations recommends analyzer measurements on floating batteries after a 2-week period on float without charge equalization. At open circuit, the battery should be fully charged and disconnected from the charger for at least 30 minutes before making the measurement. This is to ensure that the voltage, impedance, and chemical properties of the batteries are at a steady state. This concludes our video on the significance of the EC series analyzer's test parameters. For more information, Please visit Global Energy Innovation's website to watch the other training videos on IBMS and the EC Series Analyzer. You can also visit our support site to access the technological background literature in the download section. For all other inquiries, please contact us directly. Thank you.